السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. In the name of Allah, the most gracious, the most merciful. How are you, everyone? Inshallah, Rabbil Alameen, you are doing well. First of all, and before continuing talking about topic 2, the Brownian motion and evaporation, inshallah, Rabbil Alameen, today, I want to tell you that regarding the idea of sending the past papers in form of images. Okay, I tried but I'm afraid it will make large amount of it will be so difficult يا جماعة, so difficult حقيقي يعني, لأن احنا مش الموضوع كده مش هيبقى كويس. احنا ممكن نعمل discussion room لكل بيبر, لكن ما يبقاش كل بيبر على هيئة ايمج في ده هيخلينا نعمل كده discussion rooms كتيرة, ومن الآخر ده هيخلينا في الآخر we will lose the ability to find what we want to find. تمام. انا حاولت الاقي لها طريقه امبارح, حقيقي فشلت يعني. خلاص, مش حاجه او مش فشلت, لقيتها طريقه مش كويسه يعني. تمام. اتفضل يا ادهم, بس بسرعه الله يخليكم عشان عايزين نقول.
Sir, can't you send it in course material as file so we can also download it and keep it with us?
بالظبط, احنا هنعمل لهم
Solve it by hand better than on the laptop.
يعني انا هنعملها لكم, ممكن اعملها لكم اونلاين اساينمنت بالمناسبه. الاونلاين اساينمنت
Yes.
واخلي لكم الكات اوف ديت بتاعه مفتوح. تمام.
Do it like the exams, the midterm exams. We can print it and then attach it again.
بالظبط, ده يعني it will be better علشان يبقى الامور افضل واحسن يعني. طيب, توكلنا على الله عشان ما نضيعش وقت اكتر من كده في او قبل ما نبدا درسنا. بسم الله الرحمن الرحيم. In the name of Allah, the most now inshallah Rabbil Alameen, we will talk about a very important point, which is the Brownian motion. Before explaining anything about the history of Brownian motion and the relation between it and the gas and so on, let me write the title, okay, and give you a brief description of the Brownian motion. Okay, Brownian motion. Now I'll just describe the Brownian motion as a motion, regardless what is which particles are moving with this motion or something, or the reason of it. I'll describe it. Okay, to describe the Brownian motion, we can summarize the description of the Brownian motion in 3 main descriptions. We can say that they are rapid, random, rapid, random, and straight او zigzag. بلاش straight دي عشان ما تلخبطناش. rapid, random, continuous, rapid, random, continuous motion in all directions. ممكن نقول هنا as straight lines. This is the brief or 3 main points to describe the Brownian motion. يعني you have to be able to sketch alhamdulillah, to sketch the Brownian motion. Okay, so observe what I'll do now, inshallah. Okay, now this is a particle. This is a particle. To say this particle is moving with the Brownian motion, okay, we will sketch the following paths. of this particle. Now it will move in this direction. Till now, it's called straight motion. It's not Brownian motion. But here, suddenly it changes its direction for certain reason. This reason is a collision, by the way. Okay, طيب. Then suddenly it rechange its collision. Mister, for the same path? La 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 la. Unexpected path. Suddenly it goes in this direction. Suddenly it goes in this direction. If you observe, all these movements are straight lines. Mr. Should I memorize this specific figure? No, this pattern, this method of motion. This is the Brownian motion. Mr. Why is it called Brownian? It's called Brownian after Robert Brown. Someone may say, oh, Mr. I can guess. Robert Brown, this guy is a famous physicist, as I think. No, the surprise, he was not a physicist. He was a biologist. Biologist, Mr. Biologist in physics. Yes. Why, we will know now. But I hope you got the idea of Brownian motion. So this is the Brownian motion. Well, طيب. Now let's go to our notes and explain more about the Brownian motion. طيب. Here اتفضل عبد الرحمن الخضري wants to ask a question. Okay, well, welcome back. طيب, here, معلش, what was the last thing I said before the voice was cut. اتفضل يا يوسف أشرف.
We're going to talk about Brownian motion in the notes.
In the notes. طيب, ممتاز جدا. Okay, thank you. طيب, here we will talk about the Brownian motion in the notes. So the Brownian motion, we study the Brownian motion. If you observe, in the previous part of this topic, we talked about the molecular kinetic theory, the molecular kinetic model. These are just assumptions. يعني the kinetic molecular model is an assumption or a theory. So what is the experimental evidence that enforces this assumption? تمام. خليني أقول لك, this is the Brownian motion. So we study the Brownian motion in the context of proving the molecular kinetic theory, okay, or the kinetic molecular theory. So here we can say, write in your copy kinetic molecular theory or model as you like. عايز تكتب موديل زي اكتب موديل وخلاص. Okay, someone may say, Mr. What's meant by ISP? ISP is this is something in my own abbreviation. تمام؟ يعني it's not conventional abbreviation. When I write ISP, I mean it's important syllabus point. Okay, what's meant by important syllabus point? Mr. You said all the points in the syllabus are important. Yes, but when I write important syllabus point, I mean this point is mentioned in the syllabus, number one, and it almost, not always, okay, it didn't come in the exam, okay, in past papers, okay, or it's new coming to the syllabus and the majority of the students and the notes don't pay attention to it. This point is here. So because the question here may come in the exam in form of show how can the Brownian motion introduce an evidence of kinetic model, kinetic molecular model. First of all, let's go forward in the explanation. Okay, number one, the definition of Brownian motion. Okay, it's the continuous random motion of particles suspended in fluids. طبعا اي particles suspended in fluids دي معناها suspension. احنا عارفين السسبنشن عباره عن fluid with some particles are suspended in it. Okay, this motion is in all directions. طيب, here the first example is smoke, not in water. Okay, smoke in air. يعني correct this in your copy right here, air. Smoke in air. Someone may say, Mr. Smoke is a gas. It's not a particle. لا, smoke is not a gas. Smoke is a dark unburned particles of carbon. تمام؟ خلاص. These particles are suspended in air because the air is able to carry it. Okay, واضح ولا لا؟ So when you say dark smoke, it doesn't mean this is a gas. لا, it's not a gas. These are dark particles carried by air. Okay, طيب. And the pollen grains in water also. Someone may say, Mr. يعني what brought pollen grain to water? This is the story of the Brownian motion. Sir Robert Brown was making an experiment to study the behavior in pollen grains solutions. Okay, when he put the pollen grain under the microscope, he observed a very strange phenomenon. Okay, what is this phenomenon? He observed that they are moving in the solution in straight lines or in Brownian motion. He described this phenomenon and published this in a paper. Okay, so they call this kind of motion as Brownian motion, but he never talked about the gases, the gas particles, or something like that. After that, a scientist who was called William Ramsey, I think, okay, as I remember, made an experiment like we see in the figure here. Okay, he brought a piece of burning cotton or piece of burning match or any burning thing, okay, and put it in a small container like this, okay, and cover this container with glass cover or glass plate. Why? Because when you cover the container with a glass plate, okay, this container is small. At certain moment, the amount of oxygen inside the container will not be enough to make full burning uh, uh, to this material. So dark particles of uh, um, smoke will be produced, and that's what we need. Okay, so after that we will take these particles and put them here. Okay, in this system here, there is a lamp, there is a glass rod to focus the lamp on the smoke particles. Okay, because when we focus the light on the small particles, they will appear as bright specks. Okay, moving in air. Okay, by the way, we will never see in this experiment, we will never see the particles of the air. Only what we will see is the particles of the smoke as bright specks, okay, moving randomly in this form, which is Brownian motion. Well, so we will observe them using a microscope, as you see. Okay, what was the observation? The experiment observation, the smoke particles appear as bright specks moving randomly in straight paths in all directions, such that they change their directions continuously as shown in the figure اللي هو دوت الفيجر اللي موجود عندنا ده. Okay, طيب. What is the explanation? How that how does that happen? Let's see what's happening here. Okay. Now we will look at this wall, this screen to understand what's happening. Now this is the particle of the smoke. This is the particle of smoke. By the way, with respect to the air particles, it can be considered as if it's an elephant between some, let's say, dogs, some wolves, you know. The particles of air are too small with respect to the this particle. So here, these are the particles of air. طيب. So we can describe the particles of air as the following. We can say that the particles of air particle, they are light, fast moving particles. They are light, fast moving particles. But the particle of smoke is heavy particle. طبعا with respect to the particles of air. طيب, so what will happen here, Mr. A very strange thing will happen to make this particle. يعني first of all, this particle was moving in this direction. يعني ركز معايا. This was the direction of the movement of this particle. لا, sorry. This particle was moving in this direction. This is the initial direction of this particle, which is the smoke. But what happened here? The particles of air are bombarding or hitting this particle of of smoke with a large number of small, fast moving particles. Okay, so here there is large number of light or small but fast moving particles make what? Make large bombardment. يعني they will collide the particle of smoke with making large bombardment. Okay. طيب here Mr. طيب ما هو هنا في bombardment برضو. أيوة, but here we have less bombardment. يعني here we have less bombardment. That's what happened for يعني the one instant. يعني this is just an example. If this situation happens, let me ask you. Now I'll open the chat, please. Let me ask you, to which direction will this particle move? I'm waiting for your answers. To which direction will the smoke particle? Excellent answer, ما شاء الله. تمام, جميل. لا, هنا في الانستنت دي, ايوه هي فعلا راندوم بتتحرك, لكن at this instant it will move where? It will, لا, it will move to the left. It will move to the left. ليه طيب؟ خليني بس اقول لك, انا بس قلت كلمه هنا, you have to observe it. I told you here, this is, يا جماعه be careful, خدوا بالكم, this is large, لا, this is large bombardment. This is less bombardment عشان هنا عندنا lower number of particles. تمام. So the particle here will move in this direction. Due to what? Due to the unbalanced or uneven bombardment. Okay, so that's what happens in this case. So Mr. if the left side particles have higher kinetic energy move, يعني بص, هي حاجتين, larger number and faster particles. يعني larger في النمبر و faster في الموفمنت, او larger في kinetic energy, ما عندكش مشكله. تمام. 5 particles in the right. احنا قلنا خلاص كده بالنسبه للسؤال بتاع احمد, خلاص اتفقنا. وبالنسبه, ايوه بالظبط كده, ممتاز. خلينا نروح دلوقتي للنوتس مره ثانيه, ان شاء الله الصوت ما يقطعش المره دي. يوسف, انا الاي اس بي دي مش كونفنشنال ابريفيشن. الاي اس بي دي ابريفيشن انا عامله من عندي يعني للطلاب بتوعي, عشان ما تروحش مثلا ايه, ما تتخيلش ان هي حاجه كونفنشنال او حاجه عالميه. لا, دي انا عندي عشان الطالب بتاعي يبقى فاهم. اما اقول له اي اس بي معناها ان دي important syllabus point. يعني السيلبس قايلها بالنص. تمام. طب ليه بنبه على الكلام ده؟ بنبه على الكلام ده لما يكون في حاجه من الاثنين: معلومه ما جاتش في الامتحانات قبل كده وبالتالي كتير من النوتس وكتير من الطلاب بتهملها، تمام، او معلومه تكون مهمه جدا جدا وفريكوينتلي اسكت في الامتحانات وفي نفس الوقت السيلبس قايل عليها، تمام. فعشان كده تلاقيني دايما باكد على البوينت دي، اكتب اي اس بي يبقى دي امبورتنت سيلبس بوينت. تمام تمام. طيب you're welcome. يبقى هنا the explanation says the unbalanced collision bombardment، تمام، of large number of light، خد بالك large number of light fast moving molecules of the fluid اللي هو ممكن يكون air او يكون water with each large massive particle of smoke or pollen. Okay, so طبعا هنا so they move in different directions اللي هم الماسيف particles. عشان كده يا جماعه انا عايز بس اقول لحضراتكم حاجه مهمه جدا. ايه هي؟ طيب مستر you told us هنا الاول، بس عايزك تزود لي هنا في الديفينيشن، تمام. and طبعا هنا example احنا كاتبين قلنا smoke in air و pollen grain in waters وهنا gas particles، يعني زود لي جاز بارتكلز برضه بتتحرك ببراونيان موشن، دي نقطه مهمه. طب ليه بيتحركوا ببراونيان موشن الجاز بارتكلز؟ هنا مش عشان بومباردنج، ده هم بارتكلز مع بعض، لكن because they are colliding with themselves، اوكي، او يعني the other particles and they are colliding with the container. تمام ممتاز. لكن سؤالي بقى، someone may ask me, Mr. You said the Brownian motion introduces an evidence of the kinetic molecular theory. How? Okay, because the different changing in direction of the particles that we can see اللي هي particles of smoke, okay, introduced they supported the idea that they are surrounded by invisible particles. Those are hitting them from both sides, making unbalanced bombardment such that they change themselves. I hope you get the idea. So this is an example of how it shows the kinetic molecular theory. طيب let's apply fast كده. هنشوف the first question. يلا I'm waiting for your answers. طيب الأول أسمع أسئلتكم عشان في حد ناس رفع إيديها. تمام اتفضل يا يوسف.
No, Mister, I wrote my question in the chat. You already answered. Thank you.
طيب okay, you're welcome. يوسف أشرف اتفضل.
No, Mr. I raised my hand by accident.
تمام تمام. أدهم اتفضل.
I wanted to answer Mr. this question.
طيب خلاص يوسف شهاب اتفضل.
No, Mr. by mistake, sorry.
طيب okay.
But
طيب.
Mr. The smoke with air or fluid?
ما هو طيب يا جماعه كويس انك سالت السؤال ده. يا جماعه فلويد معناها liquid or gas. كلمه فلويد اي حاجه ما عندهاش فيكسد شيب اسمها فلويد، اي حاجه ما عندهاش فيكسد شيب وبتقدر تعمل فلو، يعني ملهاش فيكسد شيب وبتقدر تعمل فلو، عشان كده بنسميها فلويد. طيب اوكي اتفضل يا ادهم. ذيس خليني ادهم اعمل لك ديسكشن في السؤال اللي بعده، عشان السؤال دوت يعني ايه هسمع فيه اجابه جماعيه او هاخد فيه اجابه جماعيه على الشات وهدي لك السؤال اللي بعده تجاوبه. طيب بالنسبه للسؤال اللي هو نمبر 1 دوت which diagram best shows the path of the gas molecule. تمام the path of the gas molecule. انا بتكلم عن first question دلوقتي يا جماعه لو سمحتوا خدوا بالكم. انا علمتك ازاي ترسم الجاز موليكيول، ازاي ترسم براونيان موشن. لو قلنا الجاز molecule is moving a Brownian motion. تمام so ايوه ممتاز. طيب اللي قال دي ثانك يو ايفري ون. لا سي مش سي، هي مش سي. تمام، لان سي ده زجزاج، ده يعني بيرفكت زجزاج. لا انا عشان كده I avoid using the word zigzag. في كتب كتيره بتقول لك اكتب زجزاج، لا ما تكتبش زجزاج، هو مش زجزاج. طب يا جماعه is my voice lagging؟ علشان طيب Sebastian you can restart the session بس بسرعه عشان فاضل دقايق. ريستارت يا سبستيان بسرعه. تمام. جميل، ممكن يكون سبستيان اصلا مش سامعني. لو حد معاه سبستيان على الواتساب او كده يقول له المستر بيقول لك اعمل ريستارت للروم او للميتنج يعني. طيب نكمل كلامنا. السؤال اللي بعد كده ادهم عشان I promised him to answer. واضح ان ادهم تقريبا مش موجود، يعني حصل له كات او حاجه. طيب يوسف اشرف you're raising your hand. اتفضل.
Yes, Mr. You said number 2, right?
Yeah.
When pollen grains in water are viewed through a microscope, they are seen to be in continuous with rapid random motion. What causes a pollen grain to move in this way? So what causes it is the number of collisions, or as we said, the bombardment of the air molecules. So we can say B.
طيب ادهم انت لسه موجود؟ انا شفتك رديت على الشات. انا كنت وعدك انك هتجاوب السؤال ده، مش عارف انت نزلت ايدك ليه. are you here؟ طب raise your hand وخد المايك ودiscussion واعمل discussion دلوقتي مع يوسف، سمعني رايك ايه في الموضوع ده. اتفضل. هل انت do you agree with Yusuf or not؟
He said which answer?
He said the bombardment by a single molecule of water. صح يا يوسف ولا ايه؟ عشان انا ممكن اكون ما ركزتش.
No, it's C actually. Yes. Okay.
C.
Yes, C.
يعني انت كنت قلت بي وبعدين لما فكرت
قلت B بعدين فكرت في السؤال
Yes,
شوية.
Mr. I am with him. The answer is C.
answer
Yes.
C. Excellent answer. ممتاز يا جماعه، لان هو فعلا uneven bombardment on different sides of water by water molecules. Thank you. Thank you. It's excellent answer. Thank you Yusuf. Thank you أدهم. اوكي شوف عبد الرحمن الخضري عايز تسأل ولا عايز تجاوب؟ ثانك يو عصمت، ما شاء الله برضو عصمت النهارده اهو جميل ما شاء الله معانا. تمام. وفي تو انسر عبد الرحمن. طيب اوكي، بس اتوقع اللي بعد كده السؤال اللي بعد كده على موضوع تاني، فاحنا خلاص يبقى انت ان شاء الله ليك البريوريتي، بس تفكرني لو انا نسيت يا عبد الرحمن. تمام. ليك البريوريتي في ان انت السؤال اللي جاي تبقى انت الفيرست واحد تعمل ديسكشن ان شاء الله، لو انا نسيت تفكرني ان شاء الله. طيب then we'll talk about the evaporation, the vaporization. يا جماعه many times او يعني sometimes او you may put a cup of water مثلا in certain place exposed to air. تمام. وبعدين مثلا you travel, okay, then when you come back you find the water. Would you find the water in the cup when you come back after 3 or 4 months؟ تمام. would you find the water؟ لا الحقيقه بالظبط no, I'll not find water. طب what happened؟ تقول لي الحقيقه the water evaporated. طيب سؤال، does it require boiling؟ does this phenomenon require boiling to take place؟ لا. It happens in the normal temperature, in the room temperature. Okay, this phenomenon is called evaporation. Okay, this phenomenon بالظبط كده. So it's an escape. طب what happened here? In fact, the particles of the liquid, okay, escapes to the surface. The more energetic particles escapes to the surface of the liquid, so it becomes less till it vanished. طيب أو became less till it vanished. ممتاز خلاص. So this is the phenomenon of evaporation. So the evaporation is the escape of more energetic molecules from the surface of a liquid. And we use this phenomena daily. And for example, when we spread the clothes, okay, when we spread the clothes, in fact, we depend on the evaporation, okay, and so on. So the evaporation happens at or takes place at any temperature. It doesn't require any temperature. By the way, even at too small temperatures or too low temperatures. لكن let's talk about the vaporization. The vaporization here, لا. In the vaporization, it's changing liquid. يا ريت write in your copy, okay? It's changing the liquid into gas or vapor or steam, تمام, at boiling point. يعني هنا في change in state حصل. Change in state حصل. وحصل it happened at the boiling point. طيب. What about the temperature here? Here's the temperature it requires to happen at the boiling point as we will explain. Inshallah, but I mean, we will stop here. In next period, inshallah, we will talk about the effects. Those are affecting the evaporation and the vaporization, inshallah, to differentiate between them. Now, I finished what I want to say. If you have any question, you can ask your question. بالظبط through all the liquid صح كده مظبوط ده الفابورايزيشن يا يوسف ممتاز تمام. You are welcome. You are welcome. Okay, thank you everyone. See you inshallah next video. Assalamu alaikum wa rahmatullah.